Hi guys, my name is Vardhan and on behalf of Edureka, I welcome you all to this webinar on data warehousing. So I'll be your instructor for today, and in today's session I'm going to talk about the data warehousing concepts, okay? The various concepts that are related to data warehousing like OLAP, schemas, dimensions and facts, all these things, right? All the important topics, I'll be covering all these things in today's session. Alright guys, so without wasting much time, let me just go to the agenda slide. So guys, this is the agenda slide, and these are the topics that I'll be covering in today's session, okay? And this will be the order in which I'll be covering them. For those of you who are new to data warehousing, I will give you a quick brief about data warehousing, and I'll talk about what a data warehouse is. I'll talk about the data warehousing architecture in detail, and then I'll immediately go to the different concepts involved. So the important concepts that are there are what OLAP is. So OLAP stands for Online Analytical Processing, and I'll talk about OLAP in detail, and then I'll talk about the various OLAP cubes that we will usually work on, right? So any company or anyone working on a data warehouse, the different OLAP cubes that they work on. So I'll talk about these things, and after that, I'll talk about dimensions, facts, and measures. So these three topics are interrelated. So I'll talk about them in one segment, and the final segment of today's session is going to be about schemas. All right. So these will be the 3 or 4 different topics that I'll be covering in today's session. So guys, any doubts here? Are you guys fine with the agenda? And I hope everyone can hear my voice and see my screen. So guys, if that's the case, please put your acknowledgements in the chat box. And if you have any doubts during the session, please put them also in the chat box, and I'll get back to you at the earliest. All right. So can I get a quick yes from everyone? All right. Great. So have a couple of yeses from here. All right. Anita is saying yes. Nofil is saying yes. All right. Great. And Akbar is saying yes. All right, guys. So let's get started then. First of all, what is data warehousing? Okay, let's understand what a data warehouse is, what data warehousing does, and why it's needed, and what are the added benefits, right? So what is a data warehouse? A data warehouse is like a relational database designed for analytical needs. So you guys might all be aware of what a database is, right? So you have your database where you'll be storing large amounts of data, right? You'll be storing either in your database or even in the form of flat files, okay? But flat files like Excel or something cannot be used for storing large amounts of data. There's a limit on how much you can store in an Excel, right? So that is the case where you store data in some kind of database. So example of a few databases are those of Oracle, MySQL, Microsoft SQL Server, all these things. So you have all these databases, you'll store large amounts of data, okay? But the problem is they cannot be used for analytical purposes. So that is why we have to convert or get the data inside a database, get that inside a data warehouse, and when it's inside the data warehouse, then we can perform analysis. Now that's the advantage. So the data that once has come into the data warehouse can be used for analysis, for visualization, all these things, because you can look at the data from a different angle, because the data that comes into the data warehouse is more of an information rather than just data, right? So what you have here is just data which you can probably view, and you can write data into these places, and you can just view it from a high level, okay? You can view it from the level of every transaction that happens. So every time a sale happens, then the entire table there or the entire database will get updated, okay? All that will happen. But then when you want to perform analysis like what happened on this day and how many products were sold during this period of time, all these things cannot be gained from a database, right? So that's why we need to put them all inside a data warehouse, and once it's here, we can perform these kind of analysis and get insights from the data warehouse. And of course, inside a data warehouse, your all your end users, your business analysts, your data analysts, they can all use it for analysis and visualization, right? So that's the thing about a data warehouse, and that's the use of a data warehouse. And it functions on the basis of OLAP, right? So I told you OLAP stands for Online Analytical Processing. So the whole process of doing analysis or running queries on a data warehouse, right? It's done on the basis of online analytical processing, right? So that's one of the activities that is done. So if you're running any kind of queries on the database, then it will be called as OLTP, online transaction processing. But any kind of activity or querying and all these things, when it happens in data warehouse, it's called OLAP. So that's what an OLAP is, guys. And yeah, basically it's a central location where consolidated data from multiple locations are stored. So you get data in here from multiple locations, from multiple sources. You can get it from 1 or 2 databases. You can get it from 1 or 2 flat files. You can get all this data, as long as you are putting it inside the same table or inside the same columns and dimensions, then you'll be fine, because you can get any amounts of data from any source and you can get them all and store them all inside your data warehouse. So is that all about data warehouse? Is data warehouse so simple? Can we just simply get the data in from a database and get it into a data warehouse and then perform analysis? Is such a thing so simple? Is that going to be the question on your minds? Okay. Does anyone here has that kind of a doubt? If you guys have that doubt, please raise your hands, guys. There's an option on the right side of your panel. There's an option to raise your hands. So, I mean, you're supposed to get that kind of a doubt, and it's a very valid question, right? Because it looks so simple from the outside, but is it that simple? Yes, okay, I see a couple of hands raised from Akbar, and I see a hand raised by Anita. All right, so yeah, that's the thing, okay? It's not that simple. Now let's see what are the other activities that are involved in this whole process of converting data inside the database, converting it into an information, and storing that into a data warehouse, and then performing analysis, right? So these are the entire set of activities that are involved, okay? Now you can also consider this to be the data warehousing architecture. Now, before I explain all the activities and all the different stages that are there in this data warehousing architecture, let me first of all go to the definition, okay? So this whole act is called as data warehousing, all right? And data warehousing is the act of organizing and storing data in a way so as to make its retrieval efficient and insightful, okay? So this is the key terms here, to make its retrieval efficient and insightful. So you organize the data and you store the data in a data warehouse in a way you can access the data at a later point of time, and that kind of an access should be easy. You should be in an efficient way. You should be able to retrieve that data, and there should be a meaning out of that data. It should not be the same data that you store inside your database. Okay, so inside a database is the data that you collect. So you collect data and you store it inside a database. Okay, but the data that you get from a data warehouse should not be the same. So it should serve some purpose. It should have a meaning, and it should be for your benefit. So that's the whole point of a data warehouse. So that's the difference between a data warehouse and a database. All right. And a data warehousing is also called as a process of transforming data into information. Okay. So relevant data or more processed data, that is also called as information. So that's what is stored inside a data warehouse. And there's a lot of difference between the data stored in a data warehouse and the data that is stored inside a database. All right. So that is the thing. Now, speaking about the architecture and let me explain the diagram here first of all. So you have your data inside your different data sources, right? It can be database or a flat file, and that data should first of all be transferred into the data warehouse. But how is it done? There's an intermediate stage here that's called the staging area. Okay, the place where the data is stored, that is called the staging database. Okay, now this is a temporary storage. It's not going to be there for long. It's a very temporary storage. And the act of getting the data from here to your staging area is done through the process of ETL. Okay, so ETL here stands for extract, transform, and load. Okay, and once it comes into the temporary storage, again the process of ETL is used to transfer the data inside the data warehouse. All right, so once the data is inside your data warehouse, it's not just your data that's going to be here. Okay, it's going to be categorized and it's going to be divided. So you can think of these three things mainly. So you'll have your raw data, you will have your metadata, and you will have your aggregate data. Okay, so first of all, your raw data is the rows or columns or the actual data that's being transferred. Okay, so this makes up the chunk of the data. Okay, but metadata is the most important aspect which powers a data warehouse and which differentiates between a database and a data warehouse. Why? Because metadata is something that's going to give you data about your raw data. So whatever rows that are there in your data warehouse or whatever information that is there inside your data warehouse, right? So information about that particular data will be stored inside your metadata. So you'll have data about which are the different tables that are there in your data warehouse, what each table does, and what kind of attributes are there inside each table, what kind of information, what will be the data type of the data present in each of those attributes. So all these things will be controlled and governed by metadata, right? So without your metadata, your data warehouse is basically useless. And metadata is the so anyone who's working on a data warehouse, right, they will tell you that metadata is what differentiates everything. That's what makes their life simpler, and that's what is actually the difference between a database and a data warehouse, right? So this serves the whole purpose and the whole difference between the two. So that, and then you have aggregate data, right? So all these three things together, they form the data warehouse. And then once your data is inside your data warehouse, your end users can use this data to perform analysis. So how do they do it? They run queries. Okay, so you have user groups here and they perform queries. Okay, now the act of performing queries on your data warehouse is called online analytical processing. Okay, that's the OLAP. Okay, so such queries are called OLAP queries because they will be analysis based, right? So such queries will be analysis based. So that's why it's called on an analytical processing. And you have something called as data march here. Okay, now don't get confused because data march is again not something entirely different. It's again a part of data warehouse only. So the end users here, they can run their queries either directly on the data warehouse or on separate data marts. Now you have something separately called as data marts over here because maybe you want to give extra security in your data warehouse systems, right? So you can see here there is user group 1, there is user group 2, and there is user group 3. Okay, and each of these people, they don't get access to everything. And the whole point of even having a data mart is simply to give restricted access to your data warehouse. So your organizations or your company's entire data, right, whatever is there, that will all be stored inside your data warehouse. Okay, but what if you don't want people to get access to everything? And if you want to just give them restricted access and give them access to only certain tables and certain records, so at that point of time, you can use a data mart. So a data mart, again, it's just called a small version of a data warehouse where it will have data about a particular domain. So supposing the user group 1 that we're talking about here is something, it's a sales team, right? Then you can have a sales data mart, and the sales data mart will only have the sales data from the data warehouse, right? And then supposing this is the operations team, right? And they want access to the operations data only. So then you can form a separate data mart for the operations team called the purchase mart or something. And then based on that, they'll get access only to the data that is present inside this mart. Okay, so even though the all these things will be present inside the data warehouse, so you will get access only to this particular table or this particular domain or this particular field. So that's what the difference is. So data mart is just basically dividing your whole data warehouse into smaller parts so that different sets of users or groups get access to only the relevant information that they want. Okay, so that's what data warehousing is, and these are the various activities that are involved in data warehousing. Okay, so this is the diagram of the data warehouse architecture, and I hope nobody here has any doubt. If you guys do have any doubt, please shoot them right away and I'll answer them. Because next up is the various data warehousing concepts. Okay, now if you want to understand data warehousing concepts in detail, then you have to have complete understanding of this. I mean, of course, it's simple, so I don't expect you people to have any doubts, but yeah, if you do have any doubts, please put them in the chat box and I'll get back to you. All right, so moving on, the data warehousing concepts. Now let's understand the various concepts revolving around data warehousing like OLAP, dimensions, facts, and schemas. So first of all, let me give you a brief about OLAP again. Let's go into details here. As it says, OLAP is a flexible way for you to make complicated analysis of multidimensional data. Okay, so when we say multidimensional data, then whatever data is stored in a data warehouse, it has multiple views, right? So they will all be stored in such a way that you can perform analysis. They'll be stored, all the different tables will be linked with each other, right? So there'll be different views, there'll be different categories of data, and all these things to perform analysis, then you use the OLAP activities, right? So the OLAP queries you run on that data, and whatever data stored in your data warehouse, that's called multidimensional data. And the very act of storing it is in the form of OLAP cubes, right? So you have OLTP on one side and you have OLAP on the other side. So as you can see this line, it says OLTP systems use data stored in the form of two-dimensional tables. Okay, an example of this would be any Excel. So you will have your rows and you will have your columns here. Okay, you'll have your rows and columns and you'll have your data stored over here. So this is your OLTP systems, and any queries you can run on them and you can do all these things. Okay, but the difference with the OLAP is they'll be stored in the form of OLAP cubes, right? So there'll be multiple dimensions, there'll be multiple views that you can get of the same data, with respect to the year, with respect to the number of sales, with respect to the different products, all these things you can get a single view of all these things. So as you can see, this diagram is more of a 3D view, right? So that's what OLAP here stands for. So we call it OLAP cubes, and whatever data that is stored inside your data warehouse and whichever data you access with the help of OLAP activities, then that data is called as multidimensional data. So that's what the whole line here is all about. Right, so your data basically is converted into a multidimensional form, and that particular data, to access that data, you use OLAP queries, and yeah, it'll be stored in such OLAP cubes, right? So these are the three different things, and The next point, it says data warehousing is modeled on the concept of OLAP. Yeah, this is again, this is what I told you, right? So whatever data is stored inside a data warehouse is basically stored in a multi-dimensional form, and it's stored in the form of cubes. And to run your queries on your cubes, you run OLAP queries, right? So that's why the entire process called OLAP cubes, and processing multi-dimensional data on your OLAP cubes, right? Now that's what a data warehouse is. But with your database, however, are modeled on the concept of OLTP, right? Online transaction processing. So your databases are modeled on the concept of OLTP, and your data warehouse is modeled on the concept of OLAP. All right, so that's the key difference between the two, the basis on which these two are modeled. And your OLTP systems use data stored in the form of two-dimensional tables with rows and columns, and your OLAP will have multiple views, right? So your OLAP cubes and cuboids. So the OLAP is stored in that kind of a structure, but whereas your OLTP, here you just have your x-axis or y-axis or your two-dimensional data, right? So that's the thing about OLTP, and yeah, that's the difference between the two. And well, the advantages of OLAP over OLTP are, first of all, that when you can see data from multiple angles, right, from different angles, from different views, from different dimensions, then you will get new ideas, right? So you'll get new insights, you can think of different things, and your whole job of making analysis and getting insights will become simpler. It'll become easier with the help of OLAP activities, right? Because it supports activities like filtering and sorting of data. So maybe filtering and sorting of data may be possible even inside OLTP, okay, but there's a limit on that. So if when you have data stored in multiple tables, then you cannot do filtering and sorting of data, right? Now that is the advantage with a data warehouse. So even if you have data stored in multiple tables, you might have 4 different tables or 5 different tables, and you will have like thousands and millions of rows and transactions that will be stored in those tables. Okay, in spite of all these things, you can perform filtering and sorting operations, or any mathematical operations like calculating, all these things. Okay, you can do all these things and get the output inside one single new table. So that is the difference between OLAP and OLTP, right? All such activities cannot be supported on OLTP. And yeah, so it finally says that data can be refined. So when you can perform such kind of analysis, when your data looks much simpler for you to read, right? When you can gain some information out of your raw data, then we call it refined data. So that's the other advantage of OLAP. That's the other advantage that OLAP has over OLTP. So that's the thing about online analytical processing, right? So now I've spoken about these things. Now let's go to the next slide. So first of all, in OLAP itself, there are 3 different types of cubes. Okay, so the first one is MOLAP, ROLAP, and HOLAP. Okay, so we also call it MOLAP or MOLAP. So this stands for multi-dimensional online analytical processing. ROLAP stands for relational online analytical processing, and HOLAP stands for hybrid online analytical processing. All right. So guys, the whole topic here is OLAP cubes, right? So your OLAP cubes is where your data will be stored. Okay. Now the analysis that you'll do, the kind of queries that you'll run, they will all be OLAP queries, and they will all be on the multidimensional data. Okay. So the data that's going to be stored inside your cubes is going to be multidimensional data. Okay. But your multidimensional data, where are they going to get stored? Okay. So that is the whole topic here. So there are 3 different types of places where you can store your multidimensional data. Okay. So they are 3 different types of OLAP cubes. So the first type is multidimensional OLAP cube. Okay, when we say multidimensional OLAP cube, then this is the default type of OLAP cube. So here MOLAP is a form of OLAP that processes and stores data directly into a multidimensional database. So you have a multidimensional cube, and then your data will be stored inside that particular database. Now the advantage here is that it will give you excellent performance, and it can perform complex calculations. Okay, but the problem is only limited amount of data can be handled in your MOLAP. Okay, but then there's a difference between MOLAP and OLAP. Okay, now that's where ROLAP scores over MOLAP. So ROLAP stands for Relational Online Analytical Processing. Now ROLAP is a form of OLAP that performs dynamic, multidimensional analysis of data stored in a relational database rather than in a multidimensional database. Now what this means is that in your MOLAP, you have your multidimensional data. You'll be storing it inside a multidimensional database, right? So this will be your OLAP cubes. Okay. So what that means is you have your data that will be stored inside a multidimensional database. Okay. Thus making it a multidimensional data. and that is one type of OLAP, that is multidimensional OLAP. But relational OLAP is getting that multidimensional data, converting it into a relational data, and then storing it inside a relational database, right? So that's what it says here. It's a process of storing data in a relational database. So in your OLAP, you will have your multidimensional data stored inside your relational database, and then you will be running multidimensional analysis and multidimensional queries on a relational database. So that is the difference, right? So your queries that you'll be running, your data is basically going to be multidimensional, all right? Even your queries that you'll be running will be the same. It will be OLAP queries, okay? But the difference is the place where it's stored. The data in case of a OLAP is stored in a relational database, okay? But whereas in case of a multidimensional OLAP, it is stored inside a multidimensional database itself. Now that is different between the two. And speaking of the advantage and why OLAP can be used instead of MOLAP is because a greater amount of data can be processed in this case, all right? But in case of MOLAP, only limited amount of data can be handled at any point of time. But however, the problem is it requires more processing time and a lot of disk space. Now it needs more processing time because you are going to convert your multidimensional data into a relational data, and once you've converted that, you have to then store it inside a relational database. Now this is certainly more time consuming than your multidimensional OLAP, right? So that is one disadvantage with your relational OLAP. And also your amount of disk space that will be occupied because of all these processes is going to be greater. Now that's the disadvantage, but of course that comes with the benefit, right? So you're getting something out of using this. So that's the difference between multidimensional OLAP and relational OLAP. And then these are the two basic differences, and then you have a third one that's called as a hybrid OLAP, right? So your hybrid OLAP is basically a combination of both your MOLAP and your ROLAP. So the positives and your advantages of both is used in your hybrid OLAP. So the advantage with OLAP is that OLAP can drill through from the cube into the underlying relational data, right? So what it means is you will have your cube here and you will have the underlying relational data, right? So using OLAP, you can drill through into the relational data using your cube. So that's the thing about OLAP, which makes use of the best features of both your multidimensional OLAP and your relational OLAP, right? So these are the three different types of OLAP cubes. So this is again one important question that you'll be asked in any job interviews, right? So if you guys are appearing for any job interviews, then you have to know the difference between these three cubes, because your work will primarily be revolving around these three aspects. So guys, in the audience, do we have anyone that is going to appear for an interview very soon? Akbar, Naufal, Anita, any of you? Okay, Akbar says he's going to attend one very soon. All right, so you're still learning, Akbar. Okay, great. So he's still learning data warehousing, and probably when he's done, he might go for an interview. And the thing that you need to remember, Akbar, is the difference between these three, because there is a short question in any of your interviews, right? So any job interview regarding data warehousing and all these things, you will be asked, and you should know all these things, right? So that's the differences and the types of OLAP cubes. So moving on to the next slide. So the next topic that we have for today is that of OLAP operations. All right. So we have 5 different operations, and they are roll up, drill down, slice, dice, and pivot. Okay. So these are the 5 different OLAP operations that we can do on our OLAP multidimensional data. Right. So going to our first operation, that is roll up. Now, before I explain this, let me tell you why I'm explaining operations first of all. So I'm explaining OLAP operations so that you can understand what are the kind of operations that you can do on your data warehousing and things that you cannot do on your database, right? So with the help of OLAP, and since data is stored in such a multidimensional fashion, these kind of operations can be performed, right? So first of all, let's get started with our roll-up operation. So let's read the definition first. So roll-up is something that forms the aggregation on data cube by either climbing up a concept hierarchy for a dimension or for a dimension reduction. Okay, so when we say climbing up a concept hierarchy for a dimension, it basically means you will have a particular dimension here, right? So in this case, we have the dimension of cities. So we have 4 different cities. We have Chicago, New York, Toronto, and Vancouver. Okay, now supposing you want to go to the next hierarchy in this dimension. Okay, you want to add a couple of attributes here and more to the next dimension of countries, then you can do that. So if you look at this example, here we have converted this dimension, which is in the form of cities, to countries. So USA is a country which has Chicago and New York as cities, and Canada is a country which has Toronto and Vancouver as cities. So we have converted this dimension into the city dimension of that is present in this cube into country dimension, right? So this is the kind of operation that we've done. So we've done that using a roll-up operation, right? So that's the thing. And let me first explain this concept here, this example. So first of all, we have this cube here, and we have different axes, right? We have x-axis, we have y-axis, and we have z-axis. So these are x-axis where we have stored the different items, right? So the different types of products that are there for sale. So we have mobiles, modems, phone, and security, right? So this is the 4 different items that are there for sale. And then we have the time at which the sales were done, like different quarters of a year, Q1, Q2, Q3, and Q4, right? And then we have the different cities, Chicago, New York, Toronto, and Vancouver. So this is the z-axis, y-axis, and this is the x-axis. Now, when we say we are doing a roll-up operation, we are basically converting this dimension into a different dimension with a different set of attributes, right? We are changing this whole dimension. So in this dimension right now, we have these 2 cities part of from USA and these 2 cities from Canada. So we are doing a roll-up such that we are doing a roll-up on location and converting the cities into countries. So if you look at this here, we are aggregating these 2 attributes, right? So these 2 different attributes together and these 2 attributes together. So when you do the roll-up and when you convert this dimension, then what you get is for USA, you have the total number of sales as 2000, okay? Because it is the aggregate of New York and Chicago. So 440 plus 1560. But whereas for Canada, it's 395 because only Toronto adds to this and there is nil from Vancouver. All right, so that's what we say when we are doing a roll-up. So we are doing a roll-up on the items based on any particular dimension, right? So this dimension, we aggregated a part of this dimension and we converted this dimension from cities to countries. So this is the kind of operations that you can do on the set of attributes that will be present inside your dimensions. So that's about the roll-up. Okay, now the next operation that I want to talk about is that of drill down. Now drill down is something that is just the reverse of roll-up. So what we did in roll-up was we aggregated a set of attributes, right? So let's break down the entire attribute into smaller attributes. All right, so we can do that by either stepping down a concept hierarchy for a dimension, okay, and by also introducing a new dimension. So if you look at this example, it's a similar cube where we have similar details, where we have details for the Q1, we have the 4 different details. And basically the dimensions are the same, right? So we have the items or types for sale, we have the different time and the different cities. Okay, but when you look at this diagram, what we've done is when you say drill down, we've done a drill down operation on the time. So the time here, right, the time dimension, we have represented each of them by quarters. So Q1, Q2, Q3, and Q4. But the thing is, each quarter can be further broken down into different months. So in Q1, you'll have January, February, and March, right? So what we've done with the help of our drill down operation is we've broken down this Q1 into the different months respectively. So if you look at this one here, if you look at the security that has been sold 400 in Q1, then if you look at that, then that's been divided into 3 different months, right? So in January, February, and March, and how many products have been sold in each of those 3 different months. So this is the kind of example, right? So we've done a drill down on the time. So here it was in the form of a quarter, and we've drilled down this whole particular attribute into 3 different attributes, 3 further attributes, right, into months. And similarly, we have 3 other entries here, and each of those would be divided into different attributes. So instead of 4 different attributes here, we have 12 attributes, where each of these attributes have been further divided into 3 attributes, summing it up to 12 in total. So that's the thing. So that's the difference between a roll up and a drill down. So let me go back to the previous slide for a minute. So in this case, what we did is we aggregated these attributes and we reduced the number of attributes in that dimension, right? So we converted them from 4 number of attributes in the form of cities to 2, and those being countries. So 2 attributes in this dimension, all right? So in this particular dimension, we have 4 different attributes, and we've increased that to 12 different attributes by adding 3 attributes to each and every single attribute here, right? So that's the thing that we can do with dimensions. So that's the next operation that we can do on dimensions, right? So that is the difference between roll up and drill down. All right, guys. So all clear? All right, great. So let's move on then. So the next OLAP operation that I'm going to talk about is that of slice operation, right? So the slice operation provides a new subcube from one particular dimension in a given cube. Now, what this means is, in any cube of ours, we'll have three different dimensions, right? So we have our z-axis here, we have our y-axis, and we have our x-axis. So three different dimensions here. And what the slice operation means is, with the help of in the three different dimensions, we can use one of the dimensions and break it down into a two-dimensional cube, right? So if you look at this example here we have only our y-axis and we have our x-axis, right? So the z-axis is missing. Now what we've done is we've taken the time and we've done a slice of the time. So we've done a slice for only quarter one. So here we have different representations for different quarters, for quarter one, quarter two, quarter three, and quarter four. Now the data that is displayed here is with respect to only the quarter one. And since we've drilled down into the quarter, and since we've taken time as reference, we've replaced the time dimension here with the location dimension, right? So this comes to the y-axis, and the whole representation here is only with respect to Q1, right? So that's what you mean with respect to slice. So you slice one particular dimension, and you get into the details of that particular dimension with respect to the other dimensions. So that's the slice operation. And then moving on to the next slide, we have our dice. Right, so the dice operation provides a new subcube from two or more dimensions in a given cube. Right, so in the earlier example, we saw slice, right? So slice, what it does is it gives us a new subcube from one by using one particular dimension in a given cube. Okay, but the dice here, it gives us a new subcube from two or more dimensions in a given cube. So if you look at this example again, we have the location dimension, we have the time dimension, and we have our items dimension here. Correct? And what we're doing here is we're using a dice for a location. Okay, so we have four different cities. So we are dicing only for this location of Toronto and Vancouver, right? So because we are dicing only for Toronto and Vancouver, in our final cube, we have only Toronto and Vancouver here, correct? And then we are also slicing the time here. So we are doing a dice operation on the time with respect to quarter one or quarter two. So we are only dwelling into the details of Q1 and Q2 here. And again, the item is the third dimension which we are dicing, and we are dicing it for mobile or modem. So here we have mobile, modem, phone, and security, right? So these two are ignored, and we are dicing the item only for mobile and modem. So here if you see the x-axis, we have only mobile and modem, and after the dice, the y-axis has only Q1 and Q2, and the z-axis has only Toronto and Vancouver. So that is the three different dimensions that have been diced, right? So if you're going to get a new subcube by making use of two or more number of dimensions in your cube, then it's called the dice operation. But however, if you're getting a new subcube from your existing cube by slicing only one particular dimension, then it's called slice operation. So that is the difference between slice and dice. Okay, so we have the difference between roll up and drill down. Then you know the difference between slice and dice, right? So that's the difference between these two. And then finally, we have one operation called as pivot operation. So the pivot operation is also known as the rotation operation. Okay, it basically transposes both the axes, whether it's the x and y axis, it transposes them in order to provide an alternative presentation of data. Now, if you look at this example here, we have the location dimension on the y-axis and we have the item dimension on the x-axis, right? Now these two are transposed. Now that's what a pivot does. So when you transpose them, your item comes here and your location, it comes over here. Your location dimensions here and your item dimension is here, right? So even your data corresponding to them are transposed. So I hope you guys got the whole the concept of operations, right? So the 5 different operations which can be done with the help of OLAP data warehouse. So I hope you guys got the entire concept here, right? So the kind of operations that you can do using your OLAP activities, right, on your data warehouse. So that's the thing here, right? So these were the 5 different OLAP operations. And moving on to the next slide. So the next topic that I'm going to talk about is that of dimensions. All right. So the tables that describe the dimensions involved are called dimension tables. So first of all, to give you an example of what a dimension is, in database you have something called as tables, right? So you have different tables which will be a part of your database. Now similar to tables, we have something called as dimensions in a data warehouse. So we have dimension tables which will have a set of attributes. So our customer dimension will have the customer details like the customer's ID, the customer name, and the customer address. Okay, and your product dimension will have other set of attributes like your product ID, product name, and your product type. And similarly, you will have a date dimension which will have the order date, the shipment date, and delivery date, right? So each of these dimensions here, they talk about a different aspect of your entire data warehouse. So your data warehouse may be one for, in this example, it is that of e-commerce company, right? And as you can see here, it says the e-commerce company here, this is the subject, and the dimensions are these, and these are the attributes, right? So first of all, why would we need dimensions? Why should we use dimensions, right? So we go to the trouble of having different dimensions inside our data warehouse. Similar to having tables in our database, we have different dimensions in our data warehouse. Why should we have all these things? You can have that kind of a question. Now, the answer to that is dividing your entire data warehouse project into dimensions provides structured information for analysis and reporting, right? So when you break down your entire data warehouse into different dimensions, like for your customer details, you'll have a separate dimension called as customer dimension. For your product details, you can have a separate dimension called product dimension. And similarly, for other things, you can have other different dimensions. And when you break it down in a structured form like this, your analysis and reporting can be very easier. Why? Because when you store data, it will be in this form, right? So you will have your customer here, you'll have your customer ID, the name, address, and the product that particular person purchased, the name of the product, the ID of that product, the type of the product, and then the date as to when it was ordered, when was it shipped, and when was the delivery completed. So you have all these details in a structured format. So that's what the benefit that dimensions and data warehouse gives us, right? So end users can simply fire queries on this dimension tables which contain descriptive information. So you will be here as an end user, and you can just fire your simple queries on your data warehouse, and you will get the answer that you need. So that's what is the use of having dimensions, and that's the benefit, right? So any doubts here, guys? That's about the dimensions, and that's why we should have different dimensions in our data warehouse project. All right. So moving on to the next slide. So the next topic that we have here is that of facts and measures. All right. Now, in the previous slide, I spoke about dimensions, right? So we spoke about there being different dimensions in our data warehouse, and then we being able to sort them, filter them up using different queries, right? Now, how do you think you can run your queries and result? Because by the look of this table, you might not be able to get an idea of what kind of dimensions here to filter or which kind of dimensions here to sort. So you have that kind of doubt, right? So that's where the whole concept of facts comes into picture, facts and measures. So fact is something that helps you measure your dimensions. So what it does, let's look at the definition first. A fact is a measure that can be summed, averaged, or manipulated. Okay, and every fact table, it contains two kinds of data, a dimension key and a measure. All right, now what this means is you will have all your dimensions in your data warehouse, but if you want to perform any kind of query like any sorting or analysis or some kind of drill down or all these things, you can only do it if you have a fact. So for every dimension, you will have an associated fact, and using the fact, you can measure your dimensions. Okay, so that's what it says here. If you want to measure the data that you have in your data warehouse, if you want to measure any kind of data that is there, then you use the fact to measure your dimensions. And that is the reason why your fact table will have two kinds of data. It will have a dimension key, which will basically be the link to your dimension table, and then it will have a measure. So your measure is something that's going to calculate the data that is there in your dimension, right? So the dimension key is going to let you connect to your dimension, and the whatever data that you get from there. So whether it's any kind of addition or subtraction or any kind of average that you're going to take, or the summing or manipulation. So whatever arithmetic operation that you perform, that will be stored as a measure in your fact table, right? So that is the relation. So it will have one particular dimension key which will connect to the dimension, and the results from here, whatever the aggregates or whatever the operations performed, the results of that will be stored as a measure. So that's the thing. All right. And it also says every dimension table is linked to a fact table. Yes. Now that's the thing. Now, if you want to perform any kind of query or analysis on any dimension, then you need a fact table. That's what we are talking about in the final line here. It is only if you have a fact table can you perform any kind of queries or analysis, right? So that's the thing. And it's also a rule that for every dimension table you have to have a fact table. So you cannot have any dimension table in your data warehouse without a fact table. And that is what is the whole process that leads us to having a lot of flexibility with respect to querying and analysis and all these things, right? So take this example. In your fact table, you will have one product dimension, and then that will have a dimension key and a measure, right? So your dimension key would be that of product ID, and your measure would be that of the number of units sold, right? So your product can be your fact table, and your dimension key might be that of product ID. So you'll have all the different products that you have in your repository. And if you want to find the number of units sold, then you can perform any kind of arithmetic operation there, and measure of that will be stored over here as the number of units sold. So that is the fact table. So that's the whole concept here, right, of facts and measures. All right. So moving on to the next slide, we have that of schemas. Okay. So if you remember what we spoke about here, right, of about dimensions, facts, and measures. So these are the important topics that will help you understand the whole concept of schemas. So getting back to schemas, a schema is basically that which gives the logical description of your entire database. Okay, it gives details about the constraints placed on the tables, key values present, and how the key values are linked between the different tables. Now what this means is, you have different dimensions, or if you take the example of a database, you'll have different tables, right? So you'll have multiple tables. You'll have an employee table, you'll have a department table, and how do you link them? By using the whole primary key foreign key relationship, right? So that's the example that's showed over here. So you have one table here that is of employee table, and the other one is that of department table. And in your employee table, you have a department ID which acts as the foreign key, right? And then you have your department table where department ID is the primary key, and you use the department ID to do any lookups, correct? So that's the whole concept of schemas here in a database. But whereas in a data warehouse, we follow a similar model of primary key and foreign key, okay? But we don't use the entity relationship model here. However, we use the star schema, the Snowflake schema, and the fact constellation schema, right? So these are the three different schemas that you use to establish relationships. All right. So that's what a schema is. I'm pretty sure you all know what a schema is, right? So you guys should all have a good idea of what a schema is and what it does. But anyways, talking about the different types of schemas that you have in your data warehouse. And a couple of slides earlier, I told you that every dimension table will have a fact table, right? So that's what this diagram also symbolizes. So if I can recall, then over here I told you that a fact table contains two kinds of data, a dimension key and a measure. All right. And I told you that every dimension over here is supposed to have a fact table. It's supposed to be linked to a fact table, and it would be linked with the help of schemas. Okay. So that is the relationship between dimensions and facts. Okay. Measures is something that is going to aggregate the data that is present in your dimensions, and it will store it again in the fact table. Okay. But the fact table and the dimension table will be linked with the help of your schemas. And your schemas, if you talk about schemas in the concept of database, then it would be an entity relationship schema, right? Based on that entity relationship model, they will be linked, right? So that will be the relationship. But in case of a data warehouse, they will be using three different types of schemas, like star schema or Snowflake schema or fact constellation schema. So let's just talk about these schemas and how the primary key foreign key relationship works over here, okay, in these three different schemas. So the first one is the star schema, and in our star schema, each dimension here in a star schema is represented with a one-dimensional table which contains a set of attributes. Okay, so when we say a one-dimension table, it basically means that there will be a primary key foreign key relationship between the fact and the dimension table only. Okay, so you'll have your primary key in your dimension tables, and you will have the associated foreign key in your fact table. Okay, so if you look at the example of dealer, okay, this is a dimension table, and the dealer ID is a primary key. Okay, and in the fact table you have the dealer ID, which is the foreign key. Now similarly, for your date dimension table, then the date ID, right, this is the primary key and this is the foreign key here. And for your product dimension table, model ID is the primary key, and here model ID is the foreign key. Okay, and similarly for the branch dimension table, you have your branch ID, which is the primary key over here, and which is the foreign key over here. Now, when we say primary key, foreign key, it basically means your dimension table can have only one entry. So each of your primary keys, so whether in this case, if it's your dealer ID, then each dealer can have only one ID, right? And there can be only one date. There can be only one entry for a particular date. You cannot have multiple entries for the same date. And similarly, you cannot have multiple products with the same ID, right? So you cannot have multiple products with the same model ID. And if you look at this example, you cannot have different branches. Supposing there are 3 different branches, then they should have different IDs, right? So they cannot have the same ID. So that's why we say that the primary keys, they cannot have duplicate values, right? So the primary key over here is branch ID, which cannot have duplicate values. The primary key here is model ID, which cannot have duplicate values, and here it's date ID, and here it's dealer ID, right? So these are the primary keys in the 4 different dimension tables, which cannot have duplicate values. But however, in a fact table, you can have duplicate values, right? Because you'll be making use of the foreign key. So using the foreign key, you will be referencing to the dimension table. You'll be looking up to the dimension table, and because of that, you can have duplicate values. There's no restriction on not having duplicate values, right? So we have a foreign key relating to all the 4 of our tables, and those are the 4 different dimension keys that we have. And along with that, we have 2 different measures, right? So units sold and revenue are the 2 different measures. So revenue, we use revenue to find the total number of products that we have sold. So we'll have a product ID, we'll have the name, model ID, and variant ID, right? So each of those products, how many have we sold? So all those things will be part of our revenue. And the same thing with units sold. So each and every product that we've sold, the number of those products will be present here, and the money that we've made out of selling those products will be present in our revenue, right? So that is the whole concept of measures here. Okay, so let me just go back to this slide here. As you can see, a fact table contains 2 kinds of data: a dimension key and a measure. Correct? A dimension key and a measure. A dimension key is basically the foreign key here, which will be referencing to the primary key in your dimension table. So that is your dimension key, and your measure is basically the calculation or the arithmetic value that will be stored based on the operation that is performed on your dimensions. So that's what has been explained in this slide, right? So you have your units sold and you have your revenue, correct? So these 2 will be your measures, and these 4 will be your 4 different dimension keys for 4 different tables. So that's about your star schema. So if you understand your star schema, then it will be easier to understand the other schemas, because they are just a slight variation. Okay. But what you got to understand is the main thing is that every dimension table will be linked to the fact table, correct? So that is the one thing which you have to remember. And talking about the next point, a fact table is at the center, correct? So the fact table is at the center. It contains keys to every dimension table and attributes. All right. So it has the keys to every different dimension table, and it has attributes like units sold, and it has revenue as the other measure, correct? So that's the thing about the star schema. That's how this works. Now, going to the next slide, we have something called as Snowflake schema. Okay. Now, it's just a slightly modified version of your star schema. When we say modified in technical terms, we call it normalized. Okay. And when we say normalized, it means split into additional tables. So if you have one table which is having a lot of attributes, then we can break down this table into further tables. So that's what is happening over here. So if you look at this table, you have your fact table. Okay. Over here in a star schema, you had only your dimension table, and you had your country ID, you had your location ID, you had all these details. Okay. But inside your Snowflake schema, you have split this dealer table into 2 further tables. One is with respect to location, and the other is with respect to country. Right? So you have your location ID foreign key and your country ID foreign key over here, and they will be referenced to your location ID primary key in your location table. Okay. And to your country ID primary key in your country table, right? So that's how things work. So since your table is being normalized or split into additional tables, it's called the Snowflake schema, correct? The same thing is done here, right? So you have something called as variant ID, which is again a foreign key, and that is reference to the primary key, which is inside the variant table, correct? As you can see, so these 4 were the dimension tables that were present in the star schema. And if you normalize these tables or this data warehouse further, then you will get your Snowflake schema, right? So it's further normalized into additional tables. So that's what the difference between a star schema and a Snowflake schema is. All right. So I hope there are no doubts, guys. If there are any doubts, please put that in the chat box. All right. So that's the thing about a Snowflake schema. And then now we have one more type of schema called as Galaxy schema. Okay, it's also called as the fact constellation schema. And the concept here is that the Galaxy schema contains more than one fact table. Okay. Now we saw star and Snowflake, right? So here it had a single fact table, but the number of dimension tables were different, right? We had additional dimension tables, and there were additional dimension tables which are normalized in case of our Snowflake schema. But in case of our Galaxy schema, where you have 2 fact tables, right? So you have 2 fact tables, and you have your dimension tables such that some dimension tables can have more than one fact table. Okay. So if you take the example of our branch dimension and your date dimension, so these 2 tables have 2 fact tables. They both have the fact table of revenue and the fact table of product. Okay. But however, the product dimension table here. Okay, this one has only one fact table, that is product, and the dealer dimension table here has only one fact table, that is revenue. Correct? So to help you understand this in a simpler fashion, I've broken down this product into another dimension table, right? So earlier we had one product table here, and here we've broken down this product table into further product with respect to product ID. Correct? So that's the whole concept here. If you have more than one fact table, then it's called a Galaxy schema. So this would probably help you understand. Correct? So the revenue and product are the two fact tables, and the dimensions which are shared are called confirmed dimensions. So that means these two dimensions which are shared by more than one fact table, these two are called confirmed dimensions. Correct? So that's the whole concept of Galaxy schema. So guys, any doubts? Okay, so guys, that was about the Galaxy schema. All right, and those are the three different schemas that you can have in your data warehouse. All right, so if you're going to work on a data warehouse anytime in your future, then you can formulate your whole organization's data inside a data warehouse by using any of these schemas. Okay, they are either Star, Snowflake, or Galaxy schemas. So that's it about the schemas, and yeah, that's it. So that's the end of the session, and let me just summarize whatever I've covered in this session. All right, so I first gave you an introduction to what is data warehousing. I spoke about what a data warehouse is, how it is a benefit, and what are the activities involved in creating a data warehouse, the whole concept of data warehousing, and I spoke about the architecture here. And then I spoke about online analytical processing. I spoke about the different types of OLAPs, right? What are the advantages of that OLAP has over OLTP, and the different OLAP operations that are there that we can do on the OLAP cubes. So I spoke about all these things. And then I spoke about what are dimensions, facts, and measures. So dimensions was one concept that I started off from OLAP itself when I was talking about OLAP operations. So it started there, and then we went on to talk about what are dimensions, facts, measures, and then finally I finished off today's session by talking about schemas, right? So we had three different schemas with respect to star schema, Snowflake schema, and fact constellation schema. So these are the three different schemas that I use in a data warehouse, right? So that's it. That's the end of the session. And thank you guys. Thank you for attending the session. And if you have any doubts, please put that in the chat box, or you can email it to me and I'll get back to you immediately. All right. So all the best. I'll probably meet you all in the next session. And until then, see you all. Take care, guys.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!